Okay, let's have a go at solving some simple trig equations like this one here. In order to do that, we're just going to follow the steps that are stated at the top. First thing that we want to do is try and get sine by itself. Okay, in order to find our working angle, and we're going to use this table to the right, so make sure you've got that handy. We will show what quadrants we're working in, we'll state our base solutions, and then we'll look at the domain and we'll state our final answers from that. So let's get started with our first example here. So we're first going to get rid of this take 3. We're going to move that over the other side and add 3, and then we're going to get rid of this times 4. We will obviously divide by 4. So that's straightforward. All right, we end up then with, I'll just do it to the side here, we'll end up with sine squared x take pi on 4, and that will give me 3/4. Now we don't want sine squared, we just want sine. So that means we are going to square root, and we know that when we square root a fraction, we square root the top, we square root the bottom. And to simplify it, we have a plus or minus, because negative root 3 times negative root 3 will give me 3, and the square root of 4 is 2. It's at this point where we want to go back up and suss our table. Okay, so we're looking for when sine is root 3 on 2, and we can see that it's this one, right? This one here, which means my working angle is pi on 3. So we write down working angle pi on 3. We're then going to suss our quadrants. In this case, because it's positive and negative, it means we're in every single quadrant. So we're going to go pi on 3 up here. We're going to say pi on 3 there, pi on 3, and lucky last, right, pi on 3 there. Therefore, x minus pi on 4 will equal, right, the first one here, that is pi on 3, and then this one here, right, we've got pi, but we're coming back by pi on 3, so that means it's 2 pi on 3. And then this one here, we've got pi, but we're adding on pi on 3, so that becomes 4 pi on 3. And running out of colours, probably go back to white. So this one here, right, we've got 2 pi, but now we're coming back by pi on 3, so that becomes, you've got it, 5 pi on 3. Okay, if you're stuck and you're not happy with working out fractions, right, get your calculator out and just go 2 take 1/3, and it will tell you that it's 5/3. I like to just think of it, I'm picturing this, right, 2 pi's cut into thirds. So we've got 1, 2, 3, and then 4, 5, 6, and we're removing, right, we're coming back by 1/3, so 1, 2, 3, 4, 5. So look, whatever floats your boat, but make sure that you can work that out. Now, what you need to make sure that you include here is we have to put on the plus k lots of 2 pi, because that's the period, that's how long it takes for one lap of your sine function. Now we're nearly done, but we didn't want x take pi on 4, we just want x. So what we now have to do is add pi on 4 to each of these solutions. Normally I wouldn't write this down, but I'm going to just for this first situation, because let's face facts, I would probably just go straight to my calculator and type these in. Right, plus pi on 4. Okay, all I've done is I have got rid of this minus pi on 4, so I've added pi on 4 to each of the solutions that we had above. Grab your calculator and work that out if you want to, or I'd like to think you can do it in your head, because your common factor, common denominator lowest is 12, and then we can say, yep, that's 7 pi. So I'm just going to work that out and do that for each one. I'll pause it. Okay, so we've sussed that. A couple of things that you want to notice. Right, first and foremost, we did not subtract, we did not add pi on 4 to our k2 pi. That is because this minus pi on 4 does not affect the period, right? It doesn't affect how long the wavelength is, so we're not going to touch that. The other thing that I'd like you to notice is that these answers sort of pair up. Like what's the gap between 7 pi on 12 and pi on 12, right? We've added on to each of those, we've added on pi, and what's the gap between this one and this one? That is also pi, because they're linked, okay? Anyway, that's it for that one. Let's try the next one. Actually, I'll just come back. Just be aware, right? Because what we're looking at here, so what you're actually solving here, right? If we come back to possibly this one, right? Sine x take 4. So here's our sine graph. That means we've moved over by pi on 4, so everything's gone over. All right, so that gap is pi on 4. And then we've got plus or minus root 3 on 2. So here's the positive root 3. Oops, I wanted to make that yellow anyway. It's okay. Negative root 3 on 2. So what we've actually got, these are our solutions. Okay, here. Just nice to be able to picture what's going on. Anyway, you could look at that on your graphics calculator. And we'll come to our graphics calculator in a moment, how to do it. So now let's try this one. Okay, once again, what's the first step that we had to do? Get, this time instead of sine by itself, we're going to get cosine by itself. So the 1 goes on the other side, and to get rid of the times root 2, we have to divide by root 2. So we get minus 1 over root 2. So I've done the first bit. Second bit, get your, so go back up here. What's the second bit? Get your working angle. We look at our table. This is our saviour, this table. Okay, so we're looking at cos. When is it 1 on root 2? Here, so pi on 4. And we also remember that 1 on root 2 is also otherwise known, aka it's also known as root 2 on 2. So just recognise that. Okay, so my working angle is pi on 4. We have to do our quadrants. And we're looking at when is cosine negative. So your cosine, remember, is your x-axis, so it's going to be negative this side and this side. All right, so we've got pi on 4 and pi on 4 here. So therefore, this time not x, but this time 2x will equal pi minus 1 pi on 4, so that gives me 3/4 pi, and then we've got a whole pi plus pi on 4, so 5 pi on 4, right, and we say plus k lots of 2 pi. Now this is a bit that we want to take notice of, okay? So we've got 2x, we want to now just get x. So to get rid of that times 2, we must divide by 2. So that becomes 3 pi over 8. If you're not sure why that is, suss it on your calculator, but that's a little maths for another time. Plus, now this is the star. When we saw this question, right, as soon as we saw the 2 in front of the x, we know what that did to the graph. It squished it, basically. It made you think that there's going to be 2 of those graphs within our domain of 0 to 2 pi. So I'm expecting double the amount of solutions here, right? Because we've got 2 graphs in the space of 1. Okay, so now when we go plus k2 pi, because I'm getting rid of that times 2, I must divide by 2. So now it's just plus k pi. And hopefully you're going, yeah, that makes sense, because our graph now, right, what we had was our cosine graph was originally this, but now cos 2x becomes this one, right? So that's cos 2x. And if we're looking at, what was it, negative 1 on root 2, so somewhere around here, all right, we've got 1, 2, 3, 4 solutions, as opposed to where it hits the purple, it would have only been 1, 2. So should be expecting double the solutions. So to get all of those solutions, basically what we have to do is now keep adding on pi to each one of these solutions. And again, I'm not going to go for my calculator. No need. I know that pi, if I'm dealing in eighths, right, it's going to be 8 pi on 8. So all I have to do is just add 8 to each of my solutions. So it's going to be 3 pi on 8. And then we've got 5 pi on 8. And now I'm going to look at this one, and I'm going to add the 8 to that. So my next one will be 11 pi on 8. My next one to this, right, we're going to add on 8 to that. 8 plus 5 is now 13, sorry, swallow it, 13 pi on 8. Now I come to this one, and I'll add 8 to that, 19 pi on 8. However, we're checking my domain, which is 2 pi. So what's 19 divided by 8? That is more than, that is more than 2. So that means I have to stop. So that one's not in. I've got my max. Okay, time to do some book work. So we're going to do this first question here. Right, what was the first thing that we had to do? We had to get sine by itself. It's already in that form, so that's good. So now we're looking here. Okay, so bookwork question, as soon as we see the sine 2x, again, we know that that's affecting the period. So we're going to have double the solutions in our domain of 0 to 2 pi, because between 0 and 2 pi, we get 1 lap of sine x. Okay, when I have sine 2x, I'm going to get 2. So anyway, we go through the same process here. We're going to get sine by itself, find the working angle, and show the quadrant. So we had sine of a half, so that means we're doing this one. So pi on 6, we can see is our working angle. All right, so we're happy with that. We're looking that sine is negative, so here it's a negative a half. That means that's why we're in the bottom two quadrants, quadrants 3 and 4. So pi plus a pi on 6 is 7 pi on 6. 2 pi take 1 pi is 11 pi on 6, and we're adding the plus k2 pi. So hopefully we're happy with that. Now to get rid of this times 2, we need to divide by 2. So remember, when we divide a fraction by 2, you times the denominator. So 7 pi on 12. If you don't like that, use your calculator. And then here's a little star. All right, notice it has changed from 2 pi to now k pi. And we know, like that is the period because it was 2x, right? It's halved our period. And now we have to just basically add on pi to each of these solutions, okay? In my head, I'm seeing that a whole pi is 12 pi over 12. So I'm just adding, so 7 plus 12, right, gives me the 19. 11 plus 12 gives me the 23. I get the 19. If I add on another 12 to that, I will be over my 2 pi bit. So that's it. I'm done. Now let's go and have a look at B. Had to do it over here. Once again, we've got cos by itself. So now we have to find the working angle. So again, we go back to our table. We look at cos root 3 on 2. Now we're doing with this one. So it's pi on 6. Should clean up my table there a little bit, shouldn't I? Right, so pi on 6. Go back. We're sussing in what quadrant we're looking here. This is a positive cos, right? This answer here is positive. So in which quadrants are we positive? Cosine is positive in quadrant 1 and quadrant 4. So now we've got 0 plus pi on 2, that's pi on 6, that's how we get that one. 2 pi take pi on 6 is how we get this one. And again, plus k2 pi. When we're now looking at this 3x, we know that is going to affect our period. And in fact, we get, it's even squishier than pi a, because we're now going to get 3 of those graphs between 0 and 2 pi. So I should be predicting 6 solutions, right? So once again, when we're talking about 0 to 2 pi, instead of just having one graph there, what we've actually got is we will have 1, 2, and then we will have 3. So when we're trying to solve for when cos equals root 3 on 2, so that's like just under 1, so just about here, right? 1, 2, 3, 4, 5, 6. That's why we're looking for 6 solutions. And that's why we will actually find our 6 solutions, okay? By doing the basics things. So to get rid of that times 3, we divide by 3. And we must, right, look at this. This is 2 pi divided by 3. What's going on over here? This is just me going, well, now that I want to add on 2 pi on 3 to each of my solutions, it's easier if I have the same denominator, right? So 2 pi on 3, if I want to change that to 18ths, what did I do to the 3? I times it by 6. So what I do to the bottom, I have to do to the top. 2 6s are 12. So what I'm going to do now is I'm actually going to add 12 to each of the numerators. Okay, so we've got our original 2 answers here. So now I'm going to add 12. That's 1 pi plus 12 is 13 pi on 12. Okay, 11 pi plus 12 is 23 pi. And then I'm going to add 12 again to this one, and its little buddy is there. Right? The other buddies, right, you can see that this one, and this one are the buddies. I'm adding 12 pi to that one and 12 pi to that one. My texter stopped working. And that's it in a bit. Just one last thing. How do I know that I don't have to keep adding another 12 pi to this? Well, if I added 12 pi to that, should do it in the yellow and the color code. 20, 30, that becomes 37 pi over 18. But remember, we had to stop at 2 pi. So if I'm dealing with 18ths, 36 over pi over 18 is 2 pi, and so this has gone beyond 36, so I have to stop. Stop, hold. Okay, part C, we go on our merry way and we do everything as per normal. Okay, remembering though, tan, that has a different, we'll go here, its period is not 2 pi, it's pi. So that's why I say plus k pi, not plus k2 pi. All right, we also know that tan is sine over cosine. So where, in this situation, where is tan positive? Positive in quadrant 1 and quadrant 3. But we do everything that we did the same. So hopefully you can follow that. All right, we've got our working angle, we pop our quadrants. All right, it's 2x equals. But now what am I doing going from here to here? I have to get rid of that times 2, so we divide by 2. Notice we have to divide that period by 2 as well. So then I'm just adding on pi on 2 to each of these. Adding on pi on 2. In my head, if I wasn't using the calculator, in my head I know that 3 pi on 6 equals pi on 2. And so I'm then just adding 3 to each of these. So 1 pi plus 3 is 4. That I already had that. Plus 3 gives me the 7. Plus 3 gives me the 10. I could keep adding 3, but 13 divided by 6. 13 divided by 6 is greater than 2 pi. So that's why that we don't worry about it. And so these are my final solutions because, look, always cancel. If you left it as 4 pi on 6, it's not in its most simplest form. So just always give a round check for that. Okay. And last but not least, let's see, I'll remind you, how do we check this on our calculator? Okay. So we grab our calculator. Oops. Okay. So to do A, we're going to go, first off, I need to check that my calculator is in radians. It is, but if it wasn't, you go Shift Menu, you scroll down to angle and you can see, yep, radians. If it was in degrees, you press F2 and it becomes radians. Press exit and away we go. Option. Then we want calc, so we press F4 We want solve n, so we press F5. And we just type in sine. I love a good bracket. Probably don't need it, but I just pop it in anyway. Your x is here. Close my bracket. We want to press equals, so that's above your decimal. So shift equals, and then -1/2. I'm putting my comma, which is just above the blue delete button, comma, x again, and we're going between 0 and 2 pi. We press execute, yes, 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 more than one solution, we already know that. Press exit and you can see, huzzah, we got the right ones. So go through, practice, I hope that helps.